Hello everyone. So let start today's session. In my previous session, I have explained you lambda expression, and today we'll continue it from there. Right? So we'll discuss a thread today, and we'll go ahead with thread. If you have any questions, any clarification needed, always you can mail me, message me. You can comment on the YouTube video. So let's start. Let me share my screen. Yeah. So my screen is visible, right? My screen is visible to you all. We'll start thread. Let me open my browser and we'll go to Java doc of thread. From there, I will explain you how thread goes. It's taking some little time to my browser to open up. Yep, it came up. Yeah. Thread, Java, yeah, thread, Java doc. So you see this thread description, correct? So you can always read from thread, right? Always you can read this description, and you can always learn from Java. Java is the best resource. Any product or any programming language you are reading, their website is the best resource to learn. So you can learn it from their website directly from Oracle. See what they are saying. A thread is a thread execution in a program. Java virtual machine allows an application to have multiple threads of execution running concurrently, right? So Java is multi-threaded. Java supports multi-threading application. See, the other thing, even if Java supports multi-threading application, parallel processing, multi-threading application, your operating system should support it. Then only it will be able to work. So let me tell you something about if you are an engineering student or computer application student or computer science student, you might have read operating system. And you might have read what is a process, what is a thread, what all this you might have read in your operating system. So thread is also have a life cycle, right? The life cycle of thread, I will just share it to you. Thread is also having life cycle. You know. So if you see in operating system, the life cycle of a process or thread, here also it is similar to that, right? So you create a thread, new thread, it is runnable, then running, then dead. If it is running, if it needs some other resources, then it will go to logged, waiting, sleeping state, and it will perform that other resource activity and come back to runnable state. And then again, it will get the processor time to execute. So let's say if you have read Silver Square's book of operating system, right? So what it says, so if you all remember or not, let me show you that book. Our time, that book was very some book. Yeah, this is that book, right? So operating system Silver Square's book. This is the one of the good book which every college recommend to read. If you might have read it, if you might have read it, you might have known this diagram. This is the same diagram, and in this book, what they have given the diagram of the thread or process, new state, runnable state, running state, and dead. And then the same thing they have written IU. If you have any input output issues requirement, you will go to that, you will stay there, or if it is blocked, wait, sleep, suspend, any kind of activity will go and stay there. Once you are done that activity will come again to runnable state and then running, then dead, right? So this is how the life cycle of thread. The same life cycle Java thread follows. It's always in operating system, thread is a lightweight process, right? Thread is a lightweight process which will have a task to complete. So if you see, thread defines constructor and thread builder. So what happens here? Here they are describing about class thread, and they will describe about thread runnable, right? So I will tell you what is class thread, what is runnable, what is callable. All these are associated with multi-threading programming. Just listen to me, and at the end I will differentiate all of them. But I'll go thread, then runnable, then callable. So you see, virtual threads. See here they are saying platform threads. Thread supports the creation of platform threads that are typically mapped 1:1 to kernel threads scheduled by the operating systems. So if you have read operating system, you will know what is kernel threads and what is in Java. It is the creation of platform threads. Java platform will create one thread, and that thread will get attached to one kernel threads in operating system. So it is a one-to-one mapping. Basically, one thread to one kernel thread, right? Platform threads you will usually have a large stack and other resources that are maintained by the operating system. Platform threads are suitable for executing all type of tasks, but maybe limited resource. Platform threads get automatically generated thread name by default. Right? Platform threads are designated daemon or non-daemon threads. When the JVM starts up, there is usually one non-daemon thread. That is the main thread. When you do right-click run, your public static void class run, that is that is the default one thread get created. That is called non-daemon thread. The shutdown sequence begins when all started non-daemon threads have terminated. Right? Unstarted non-daemon threads do not prevent the shutdown sequence from beginning. Right? The shutdown sequence begins when all started non-daemon threads have terminated, and unstarted non-daemon threads do not prevent the shutdown sequence from beginning. See, whatever you are reading here, whatever I read it here, I will show you all by creating a different examples. So we'll go slowly. This thread might take one more session also. We'll go slowly. We'll try to learn what is thread. And this is what yesterday's Lambda example program. I think we ran it, and so what was something was there, right? We left in between that. I said I will do it. So I think yeah, it was printing that 19 twice or something like that, right? This is that? Let me run it. Or it is previous to previous session. You had not found. Yeah. So this is how it is executed. That is that previous session thing, right? So if one program is having some issue, you might have executed it, you might have seen it, the output, how it comes, how it happens, right? So let's close all these Lambda expression. If you have any questions on Lambda, you can always mail me, comment me, and I will explain you that. So here I will create a new package, where I will have all my thread programs. So your com dot example dot thread. That is the pattern I'm writing for the package as com dot example and then the topic name. So here I will create one main class first. Main class. And then I'll create I'll create one user thread class. User thread class. Okay, this is what user thread class. In main class, what we'll do, we'll execute all these threads. So thread class should implement, no, should extend to make this class as a thread class. It should extend the class thread or interface runnable or interface callable. Right? It should be this way. And what then you have to do? You have to then do something here. Let me go first to the thread class. See, thread class is again implementing runnable interface. Right? Runnable interface is which whoever implement runnable interface, they will become a thread class. Right? So, and what you have to do? You have to basically override the run method of that particular. This is the run method which you need to override. This is the run method which you need to override to perform the task, right? Or to create your own thread. Basically, what it says, it is always better to implement thread for user thread class. But for an sample or example, I'm saying I am showing this example with extend thread, but it is not the right way to do, right? So here you have to do public void run. You have to implement run. This is how the run method, and you have to implement the run method. See public void run. We have to override that method, and whatever we do inside that, that will get printed. So let's say simple. I will print a system.out.println, right? The world thread new thread. This is I have done new thread, right? This is this is creating a thread from the thread class. But what we have done here, we have created our own user thread, right? So for that also you can go that way. See thread, sorry, not thread. Again, make it first. So user thread, right? User thread, user thread, equal to new user. Using this user thread, dot run. User thread dot run. If you do this, what will happen? If you will do this, it is just you are calling another method. You are not executing a thread. It will give you the output. See, it will give you the output when you initialize a thread. The same way it will give you the output. See Java world. But this is just like simply calling a method, and you have only one non-dependent thread. That is the main thread, right? So this is not the way you should do it. This is not the way you should do it. So that stack. When you do stack, what it will do? Java world. So when you do start, it will create another thread and it will execute in that thread. Main thread will be different thread and this will be different thread. How to know how to differentiate both are different thread, right? So here what we will do, sys thread name. Thread dot, there is something called name, one method is the name. Hmm, thread dot current thread dot get name, right? So this is what this I'm painting it here. So I will copy this thing to the main method. Here I'll paint it. See what output you are getting. So here it is. I will say, yeah, thread name. Let's say thread name. See thread name main, thread name thread zero, right? You got two thread. So if I comment this user thread and the earlier way what I has done, right? Method call user thread dot the method run. What it will print? Let's see what it is printing. After a long time, I'm doing this cover. See, thread name, man, thread name, man, right? So we are only in single thread. It has not created another thread. So this is how thread. If you want to create a new thread, you have to do thread dot start. Then only a new thread will get created. Otherwise, it will execute in the same main thread, right? So this is not the right way to do. Whatever I have written in line number 10 is not the right way. This is the right way to create. You can use you can create a thread this way and then use a thread dot start. It will create a when you do dot start, it will create a new thread. Now, what you can do, let's say you want, you want this thread to sleep for some time and then get a resource and execute it. Thread dot sleep. Let's say 1000 milliseconds, right? 10,000 milliseconds. But it is giving error. It will ask us to write try catch because of interrupted exception, right? So this interrupted exception try catch I've added it here. Now I will put it here as sys, to say so how fast it is executing. Java is talking. Java is evergreen, right? I will write evergreen. Right? Java is evergreen. Now this is what we want this guy to sleep for 10,000 milliseconds and then execute it, right? Then execute the print the below line and then this. So once the thread is completed, well, let's go to main class. Once this thread is completed execution, here it will print your main and then with the thread, stop. You can stop. Stop is deprecated because once the thread is completed, it will automatically stop, right? The stop is not required anymore. So what you can do, you can just want to check the state of the thread. So you can do user thread dot get state. There is a method, it will give you the state of the thread. Okay. So I'm just checking something there. Fine. Checking one second. Hold on. Okay, get state, right? So this is how it should. See, returns the state of this thread. That is a state object, right? It returns the state of this. This is what it returns. Let me print here that state. Directly print me the state. Let's see what posting is from it here. Now, if you see this main thread, what it will do, it will start the thread, and inside the run method, what we are doing, where we are trying to print this Java world thread name, and then we are making the thread to sleep for 10,000 milliseconds, and after that it will print Java with Java is green, right? This is what the child thread is doing. And what main thread is doing, main thread just invoking the child thread, and that's how it is. This is how. So let's run it. So see, thread main class, then runnable, then the thread name thread zero, Java world, Java is evergreen, it stopped. So what it did, it basically printed the Java state here, right? It basically printed the Java state. What is this? This is a runnable state. State of thread is runnable. It printed main class, then it printed runnable, and what happened? Then thread main, thread name, thread zero. See, after creating the states, user thread dot start, you cannot guarantee that this thread will get executed same time. For example, let's say we cannot guarantee which thread it is going to, which thread it is going to execute in particular time in operating system. That's how it depends on the what kind of algorithm operating system is having. Always, this thread in they uses the operating system algorithm sometime. Some, Sometime, you have to be very careful while writing these thread applications. If you have multi-thread applications and you are writing multiple threads, nowadays no one write thread because there are so many frameworks which are really handling the thread applications. So if you want to do it, you need to learn the in-depth concept of thread and then do this threading concept, right? Now I'll create one more user thread class, user thread, right? User thread. It is extends, right? It is extend. Then here we have right thread, right? The same thing. What I will do, I'll copy the same thing here. The run method here. Just because I'm writing this, I'm writing this to show you the concept, right? I'm writing this to show you the concept. So this is what I did here, right? Now let's go to the same thing, nothing different, the same thing. Here I'm printing it here, based on the thread name, you will come to know what it is printing. So what we will do, this Java word will take after thread name. I will print after the thread name so that it will clear this Java word is coming from which thread. So here I delete this, right? So see, here also we'll get the same thing. Here main thread, it's simple, it will give main thread, right? Now let me go to main class and create, after user thread, I will create the other user thread object. Right? Now for this guy also will do the same thing here. Dot, right? Dot stat. Now instead of getting the state here, we will comment out the state part. I will say main class exit, right? And here we will say in first user thread, we will say exit after sleep. where, oh, it's printing something here. Yeah. So here what we'll do is let's say print this something at the end, right? So you'll come to know which thread is getting executed and which thread is doing what after what. Okay. So this is how we are printing in both the thread class. The same thing I'm printing in both the thread class. Only thread name will differentiate which thread is running, right? And this again. One more thing I will do because when it represent thread name, we don't know which thread it is, right? So what you can do while creating this class, right? While creating this class, I'll show you one more thing. While creating this class, you can set the thread name. Thread dot set no dot get is something you can set. Set context, set domain, set name. Yes, this is. I think what is on set name. Let's say we'll set it as thread one, right? And this user thread we'll set it as thread two. And set name what we'll do? Thread A, thread B. No, no, numeric. Thread A, and here we will do thread B. Thread B. Right? So we set their name. So it will print the same name. Now let me run this class. See, thread main class exit. It started both the thread and then the main class exit. Thread name thread B Java world. Thread name thread A Java world. Thread B is evergreen. Thread B exit. Thread A is Java is evergreen. Thread A exit. See, now what we did, we started thread A first. Then we started thread B, right? So see here what it has done. It executed first thread B and then thread A. So see this thread, whenever you cannot say when thread A will get executed, when thread B will get executed. See now in this particular situation first, thread A got executed, then thread B. So that's how that you cannot give any guarantee when this thread class is or when the thread is going to execute. Right? So this is what the concept of thread. This is a simple example I've given you in thread. Now what I will do, I will show you the same thing with runnable. Right? Then we'll go for callable, and after that, what I will do, I will show you a few complex program, right, where you can have thread for your implementation. That I will show you. So let's go for runnable. Same only same example I give. I will not, add anything new. The same whatever I have shown you, the same example I will give. So giving first how runnable can be created, how a thread can be created, then how callable can be created. After that, I will show you some complex or maybe some example which is really having a better business logic, which can be that need thread to be implemented. Right. So here we'll say user runnable. What it will do? It will implements runnable. Right. Now it implements the runnable. So what it need to do? Why it is showing error? Because you need to add on implement method that is run. I'll copy the things from the run. Right, I'll copy this method directly there. See why I'm doing this copy paste rather writing another business logic. It will be faster for me to explain the concepts of runnable and thread. That's why I'm doing it here. So let me create one more runnable to show you the better or to give you the better example, right? Let me show one more runnable. Okay. Now here I will do implements runnable. With same thing I did copy paste. Now what I will do, I'll go to main class. And here I will comment whatever we have written for thread. We will go with runnable, right? We'll go with runnable. So these all are commented, right? You see, runnable is an interface, right? And this interface, I can, what I can do, this interface has one method that is run, right? So this is little bit, you cannot directly, what you have to do, we have to create a thread like this, and equal to new user thread, new thread, create this new thread, and then you pass new runnable with not new runnable, new user runnable with, right? This is how we create and thread instance using runnable. If no, this is how you create. I will show you the other approach. What you might be thinking now. Why not directly? The user user runnable equal to new user runnable new user runnable dot start. See, there is no start method in user runnable. So by creating an object, I cannot start. By creating an object of runnable class, I cannot start. But I cannot start the thread. I have to start the thread using the thread class object. So that is the only way to create a thread or to start a thread, right? User runnable dot I can call run method. But again, if I'm calling run method, you know what it is. It will be always like calling a method. It will not be the, so before calling, what I should do? I should take this current thread thing. This is always required. Let me run it now. Huh? See, thread main. It is always thread main, right? So there is no benefit if you do like this, use runnable run, because this is always going to call the method invocation. So to do that, to start a thread which implemented runnable interface, you have to go with the approach which I have shown you. What you can do, I brought that line to line number 26. Take this user runnable object and pass it. Yeah, rather creating new, already we have created new. So the same, either you create inside or you pass this way. Both of them will work. Now this line is not required. Here what you have to do, you have to do the same thing. User thread dot start. Right, user thread dot start. It will start the thread. See, main thread, then thread 0 Java world. And since we have had it thread dot sleep for 10,000 seconds, it is going to sleep for 10,000 millisecond, and then it is going to print out the output. Right. So this is how this thing, and the same thing for the you have to do for the user enable class. Let's do that. Right. User enable class. So here you do thread dot user thread. Say both of them are going to sleep now for 10,000 milliseconds, right? After that, they will say, what do you print it? See, what? So this is how you use Runnable to create the object. Now we will do a little bit of tricky thing in the particular Runnable interface. Rather only sleeping, what we will do, we will have a for loop here inside the track. You know, we'll just have a simple for loop here, and in that for loop, we will just 10 times or yeah, 10 times will iterate, right? And we'll keep all these messages inside that thread loop for loop, right? And rather making it sleep for 10,000 milliseconds will make it sleep for 5,000 milliseconds. 5,000 milliseconds. The same thing I'll copy from here to that. The other one. Why I'm showing you this, just see how it works. You know. So now what actually is logic? Inside for loop, it is going, it is going to iterate 10 times and it will hold for 5,000 seconds. It will sleep for 5,000 seconds and then it will execute. Then sleep for 5,000, then it will execute. So that's how it is going to do, right? So see how the output is going to come here. People, if you want to learn more in thread, whatever I'm teaching here, if you want to learn more in thread, connect me. I will discuss. Message me, right? See how the things are getting printed. So it will iterate the loop, it will print, right? So what happens now when we have multi-threading program, we always look into different kind of threads, how they perform, how they work, and accordingly, how. If you see this program on games, right? Games. If you see online game you're playing or any game you're playing, they all are multi-threaded, multi-processing, applications, and they have implemented threads so efficiently that you are not able to identify parallelly multiple lightweight processes running, executing and giving a beautiful uh, picture or beautiful look and feel of that particular game and you're able to play, right? This is how this example I have shown you, right? And if anything else, let me go to, it's been a long time, let me go to this, Dr. Java doc, what they're explaining, uh, thread virtual dot factory. So there's something called thread factory, which we can have, you can create a different kind of way to implement your thread inheritance and creating. I will talk about what is factory pattern in my coming sessions, where I will talk what is a factory, how we create an object factory. Based on that, this thread factory concept comes here. So inheritance, when you're creating a thread inherits its initial values of inheritance, thread local values, including the context class from the order. From the parent thread values at the time of the child thread is created. The five param constructor can be used to create a thread that doesn't inherit its initial values from the constructing thread. When using a thread builder or any inheritable thread locals method can be used to select if the initial values are inherited. See, here what they're saying, you come to this thread class, right? In thread class, if I go to the top, right? If I go to the top, very top. You see coming down. Hold on, control. Is, see thread constructor. This is the fast thread constructor, right? It is taking this dot null, right? It is what is this method is doing? Initialize a new platform. This constructor has the same effect as a thread group runnable string. This thread newly generated, automatically generated names are of the form of thread. This is what he's trying to tell. If you go to our main class and if you put our mouse pointer on the thread class we created here, that same definition, you will get first one. Because first one we created. Yeah. See, it is what he's saying. Thread, runnable, initialize a new platform thread. The constructor has been the same effect as thread null task gname, where gname is newly generated name, automatically generated names are of the form thread, where n is an integer. Right? So this is how you can read the description and you can always implement the thread. See, this is what we're using there, right? Similarly, you have runnable address runnable, etc. So many threads are there based on the requirement. Based on the requirement, you can, based on your requirement, always you can use the thread constructor which you want to create or create an object or initialize the thread using or runnable classes using that, right? So now coming back to callable. Do you see the main difference between runnable and callable is what? The callable will have a call method and it will return a future object, where runnable is not going to return anything. Let's say you have a thread and user and your thread after execution it has to return some value. You cannot return that value using what runnable interface or thread class, because both of them what they do, both of them have void return type, right? They don't return anything, so you can't return. But if you go to callable, you see java.util.concurrent package. It is coming from the concurrent package. So I remove the generic initially. You know what is the use of generic by this time if I go watch my all the videos. So this callable will return as an object, and that object is called future object. This is going to return an object, and this is the object is of type future, right? So callable, I will just read what is this callable. See, callable is an interface, right? Here in top a task that returns a result and may throw an exception. It's better to go there, in the user callable class, yeah, and point out our mouse there. It will give the definition. Yes, it's not giving the definition. No, okay, let me read from there. Is a task that returns a result and may throw an exception. Implementer defines a single method, no argument called. The interface is similar to java.lang.runnable. It is similar to the runnable interface. In that, both are designed for classes whose instance are potentially executed by another thread. Right? Executed, what it is saying in that both are designed for classes whose instance are potentially executed by another thread. However, does not return the result, and a runnable class or runnable class doesn't return any result and cannot throw a checked exception. But here callable, it is returning a result and it can throw what it can throw your checked exception. Right. So how we are going to have this? So let me go to Java doc and show you some example of uh, callable. Callable interface, callable Java doc, right? We will do that. Callable Java doc. Callable, this is Java doc of callable, right? This is a functional interface because one method you have, as I described in my lambda expression, what is a functional interface. Wherever you have one method that we call as functional interface. Right? So they think this is a functional interface, right? And can therefore be used as the assignment target for lambda expression or method interface or method reference set. You can do that. A task that returns a result and may throw an exception. Implementers define a single method with no argument called call. Right? The callable interface is similar to runnable. In both are designed for classes whose instances are potentially executable by other threads. The same thing we read in the Eclipse. A runnable, however, doesn't return a result and cannot throw a check exception. But while as the callable return you one object, right? And to run this callable class, the executor class contain utility methods to convert from other common forms of callable to classes, right? There is another called executor class. You need to use executor class to execute your but callable class, right? So we'll see now with examples how we can do that. Okay, so let me go to this user callable and implement this callable, right? Implement this callable with some dummy logic, right? A long time back, I had one requirement where I need to uh, basically do something with the file system, something with text files, .txt file, which I have to process because the text file contains some information. I have to process it, and I have to do it in a faster way, and time period is very less. So I have written a utility program kind of thing for using this callable because I need to return output using this callable and executor service. This I will show you. I will not show you that example, but I'm telling you what are the advantage of callable and executor because callable always return some value, and if I want to use runnable, then I can't return that value, but I need to, let's say thread one and thread two are executing. Once they both return the value, I have to do some manipulation both the return value, and then I have to go to the thread 3 to perform the output or perform the final stage of processing. That only can possible with callable, right? Otherwise, because callable will give you an object that can also be done using runnable, but that is a little bit critical, and you need to use lots of things to process that particular kind of operation. So let's say here what we will do, let's say we will create employee object, right? Already have employee object inside the collection. We'll use that. Employee, what to employee, to employee. So we'll set the name. Dot set name. See, this is what return employee we are doing, right? This will be always object type. This will be always object type until unless you want to implement this generic. If I implement this generic, then I have to, you know, I can return that particular type of object. Now here, if I keep that employee in this object, it will work, right? So that is the advantage of generic to make your class more specific what it is returning. So let's remove this generic and do it in a normal older way and see how it works, and then we'll talk about generic. Let's go to the main method, right? In main method, if I do callable, user callable, right? User callable, not runnable, user callable, equal to new user callable. This is what I'm getting, right? Dot. See, if I do dot call, what it will do, just see it, what it's doing, right? I have to handle this exception, right? I have to add surround with try and catch because it is going the exception if I do is user.com, right? So see what it is doing. It is just calling, right? Main It is just calling when, uh, sorry, sorry. Let me comment out this thing, the runnable part, right? We are done with runnable part. Let me comment out this. Yeah. And if you see, let the execution finish. It is only for few seconds only. I can stop it. I stop it. Fine. So now let me run it again. What happened? You dot call I did. Are you printing anything? Okay. Are you printing anything? Future. Dimension can convert from the object to object. Fine. Let me do object. Okay. Down press. Right. Yeah. Now I have to print that. Let me run it by doing this much. Okay. What it is doing. Is it showing any exception or is it printing? Yeah, class cat exception. Employee cannot be class to content dot future. Okay, so directly it is returning as employee. Okay, make it. Yeah, because it is not a thread, correct? It is not a thread. We are not creating a thread. That's what I was getting confused. Hold on, little bit. Let's see. Create a thread out of it. So this is just a simple method call, right? This is what we are doing is just a simple method call. This is simple method call. This is not going to, you know, say, or this is not going to create any thread. Just to show you that, I'm trying to print it here. Thread name. The same thing I'll print inside the callable this method, right? So now again I will run it in the main method. See, it is always main, it is always what it is always inside main thread. This is not the way how we call or how we create a thread using callable. Creating a thread using callable, if I want to show the thread style, right? That is going to help to create a thread instance using like this. No, because thread won't take callable. It only takes runnable, right? It won't take callable. So executor comes into place here. Execute. So what is an executor? Let's go to that Java doc. Let me tell you what is an executor here. See, executor, public class executor, extends object. It's a factory and utility method for the executor service, scheduled executor service, that factory and callable classes defined in the package. This class supports the following kinds of methods. Methods create, execute, and return an executor service setup with commonly useful configuration setting. Method creates and return a scheduled executor service setup with commonly useful configuration setting. Scheduled executor service basically whenever you want to execute a thread, let's say throughout the day midnight you want to execute that thread, so you can use scheduled executor service where you will press the time. So that's how. So executor service is always used for it. Now, if I go here Executor is an interface. Yeah, right? Executors, executors equal to the service. Wait, what happened? I think I'm doing something wrong. Hold on. Okay. Yeah, this is what is that class here? Concurrent only, right? See, concurrent executor services. Okay, so I am doing something wrong. It is basically executors dot new fixed. Yeah, you have to use the executor dot new fixed. So this is basically we are going to create. It's been a long time. Executor service, executor dot new fixed thread pool, and then we have to execute it. Right. So let's go here. Executor, then you go create executor dot new thread factory, new thread pool, right? So let's say create 10 threads, right? And it will be executor service, that interface, right? It will, we got your executor object. Now here you can do like this executor dot uh, submit is a method which will take your callable, right? Which will take the callable. So now we are submitting this as a thread or task to executor service. Let me run it now. See what is the output getting. Thread, main thread name code one, thread one. Right? Now we want to print that output. What you will do, you will go to this executor, you will fetch that control dot executor get executor dot something we use here. That's all the right thing, right? Executor dot. Uh, it will return itself, right? Why I want to do get. I'm all time get is getting confused. So yeah, see, not confused after a long time, so little bit. Future equal to, that's how happened, right? Future. This is how you are. Executor submit will return your future object. And from this, you, you get your output. Dot get dot, future dot get will give you the employee. The employee. And from there you can get the name. Right? Now let me run it. What it is showing. It will throw some exception. We have to, you know, use that. It is going to throw interpret exception or execution exception because it is a thread, right? If something goes wrong, if future, if future is, future has some issue, it will throw that error. See, Satya, right? See what actually happens. Earlier, if you have seen this main thread will get complete, right? Main demo will get complete. But if you have seen this previous example, when we are having this sleep, thread A and B will be running. but main thread already its execution is done. It has left. It has completed its execution, right? So here you see, I'm writing a thread name and I'm writing again exit or done. Hmm? It has done. It has dead now. Main thread. See the output. Thread main name main done. It will always come after executing the complete thing. So here what I will do, I will try to put user thread. When I will take this sleep, I will put for sleep. I will ask that colleague to sleep for some time, and you see what it is actually doing. Right? So we already added sleep. And since this guy is throwing exception, no need of handling try catch here, no need of handling interpreter exception. But what we did in Runnable, or what we did in Runnable or thread class, we always handled it with try catch by having interpret exception or to handle it. But in case of callable, in case of when you're implementing callable calls method, we do not require to add, any kind of try catch, throws exception it is throwing. So by default, it will catch all the exception. It will throw all the exception to the parent class or calling class, right? So let's go here to the main class now, wherever we have this, and let's run it. Right? See, thread main started and the callable thread also started. That is pull one thread one, but it's not main is not ending. After printing Satya only main got end. Why? The reason is it has to fetch the fetch object, future object. No, it will get only future object only after the completion or complete execution of the thread, and then it will do the thing. I will show you how. I was telling about the text file, reading names, and doing something in one of the project which I worked with on my one of the organization. Here I will show you similar kind with this, but it will be bit different. Let me create another class. Why I'm running? I need to create a class, right? So here I will create again same user callable. Here same user callable. I'll just make C user callable class, right? I'll add class. I will take the same functionality from here. I will add it here. That's it here. And here I will say implements callable, right? So now this is what it seems to be, right? This is how we did. So here I will say my wife name, let's say. My wife Madhusmita Sahu. So her site name is Madhu. Right? I will set Madhu's name in this thread. This is how it works. See, I have created, what is I have created? 10, 10 threads for this callable. It is going to execute with 10 threads, right? Now, this executor.submit, I have given callable, one callable. I will call this guy, oh no, I'll create one more that user callable class, right? Equal to user callable class. This is what I've done in line number 41, right? And then what I will do, I will have one more future return object here, future, future, equal to executor dot submit, where I'll pass callable class, right? So here I'm passing callable class in line number 44, in line number 43, I'm passing Callable class in number 43, I'm passing. Yes, you're getting confused. Line of future equal to executors dot submit callable. That I'm passing there. And in line of 44, future equal to executors dot submit callable class, right? Let's go here. Another here, what we will do, we will not print, we will not only print that. What we will do, we will get out of future, the employee object, right? This employee object will print string equal to, this dot get name plus, right? I'll copy this thing, we'll put it on the other side. I'm just creating a new string out of it, get double E, right? And here, right? And then this I'll print. See, this is taking time because I'm writing code in front of him. You all, if I would have kept ready-made code, I would have just explained. That won't help, for beginners or freshers, those who are really interested to learn. This approach will help you to learn many things. While parallelly you are looking into the video and parallelly you are practicing the whatever the example I'm giving, and then parallelly you are looking into books or internet for the same, some theory content from internet. See, Satya plus Maru, right? Thread name, main done. You getting? If I go to the user callable here, my full name I'll put Satyananda, right? Here I'll put my wife's full name. So let me run it. Now what you get? See, one more thing you might have observed. Main class or main thread is exit, always going to dead state or exit state after the completion of child threads. But in case of thread and runnable, it doesn't matter. Main thread will complete, but child thread will be running, right? So basically you cannot say that my main thread will wait for the child threads. But here, definitely your main thread will wait until unless your all child threads are or have completed their execution. So let me go to the main class. It's still man is waiting, right? Man is waiting the child to complete. See, Satyanand Sahu plus Madhusmita Sahu. Then the main done is exit. See, nowadays you have so many frameworks, right? Nowadays you have so many framework which is handling thread very efficiently. So people don't write their own execution class. They don't write this kind of logic nowadays. If there is a complexities which cannot be done using third party frameworks or some other framework, then people they write executor program, a program using executor service, and they do. See, tomorrow I will explain a little more about callable, and I'll give the difference between thread on callable runnable in coming session. That might be tomorrow session, yes. So every day I'm uploading video. If you're really interested to learn Java and go in depth, learn it from my videos. Whatever content I'm trying to put on the videos, most of them from this Oracle certified post content. I might have missed something because I'm not going through all details, but I'm going through the details which will help you to become a good programmer in Java. Learn it and let me know your feedback and the reviews. So thank you everyone. Let's meet in coming session or next session and talk more about callable, thread, runnable. Okay. See you. Thank you. Thank you, everyone.